Process control. The process control, it can be defined as manipulation of process variables so that the desired product attributes are obtained. So whenever there is a process going on in a food processing environment, there are a large number of variables, and some of the variables may bring about some undesirable change, or something might get out of control. So at that time, we have to manipulate certain variables to bring everything back into control. And that would make us sure that we are going to have consistently same quality of product and good quality products at the end, so there are lesser deviation in the final product. And this is one of the very important area for food processor to reduce the chances of error, or to reduce the products with faults, because that would involve economic losses, a lot of rework on those products, and that may also lead to recall of those products from the market. So all these operations are not, these outcomes are not desirable. So that is why having process control in a system is really highly valued and highly important. So these variables, as I said, there may be a large number of variables for a single process, and every variable have some outcome or some effect on the final attributes of the product, and we have to look at them in detail and with very fine detail that these change in product attributes are desirable or not. So once, as I said, that we can control these variables, all these process variables, the consistency of operation is achieved, and that would mean that it would reduce the cost of production, and improvement of safety would be achieved if everything is under control. So whenever there is a deviation in any equipment for the work that the equipment was supposed to do, there has to have some automated control that would bring that equipment back to its normal function. And generally, most of the food processing lines are equipped with these automatic responses and the process control measures, because in today's world there is a very high throughput systems or product lines when we get a large number of products in very small amount of time. So if we rely on human resources or people inspecting everything, it would be beyond their scope or beyond their capability to actually pinpoint small or minute errors, and in many times they are not observable. So having these automatic process controls are far better than employing these human inspection elements in a setup. Then the productivity would be enhanced, because there would be less failed products, or there would be less products that are out of specification, and that would increase the efficiency of the systems. And as I said, in today's world, these operations are very much automatically controlled, so they provide very high level of screening of unsafe conditions that can lead to food safety problems. And now with the development of new sensor technologies, we have got a large number of sensors to detect very small or minor changes within a factory setting, and they can quickly adjust themselves to bring the system back into the control. So they are very much efficient, and they can be very economical as well. If you look at this picture, if we look at a process in the middle, and if there is any disturbance that takes place in this process, we have to go for the control variable, and these control variables are applied, and then we look at the next measured value with a sensor. As I said, there have to be sensors for all these variables they are far superior than human senses. So these sensors would actually measure these values, and they would be set point already decided by the management, and this feedback is given back to the maybe to the operator that there's something that has been, whether these variables are out of control or within range. Then they would have required values of manipulated variables, and then the variables would be changed, and it would look back into the process and see whether that disturbance has gone or the variables are still out of control. So this is a feedback mechanism, and this diagram represents the flowchart of overall feedback mechanism for an automated process control. So as I said, there are different sensors that they would be looking at any deviation from the normal processes, and similarly there are different valves that are employed to adjust things. For example, I would take an example of milk. When we have to make sure that the milk that is produced, whether in the pasteurized form or sterilized form, it is properly heated. So we would have sensors attached towards the end of these processing lines, and will monitor the temperature, whether it has been achieved or not, the internal temperature of the milk. If it's desirable, the process would go on as normal. But whenever there is deviation in the temperature, or whenever the temperature is lower than the required values, then there would be flow diversion valves. That would mean that this milk would not go to the final product, rather it would be turned back into the processing line again to be heated again. And that would make sure that every product that passes through that endpoint is properly sterilized or pasteurized, whatever is the desire from that end product during this process. So this was some detail how process controls are important and how they are employed in food industry.